Equivalent Boolean expressions are Boolean expressions that evaluate to the same value in all cases. So no matter what the input is, the expressions will always evaluate to the same. So for example, x less than 3 is equivalent to not x greater than or equal to 3. So no matter what x is, the value of this expression is the same as the value of this expression. To help us evaluate whether or not two expressions are equivalent, we have something called De Morgan's laws. So in this example, A and B, we have to assume, are Booleans. You can also think more abstractly as A and B are Boolean expressions themselves. So if we have the expression not, and then in parentheses A or B, that's going to be equivalent to not A and not B. And we know that because we can write a truth table. So we have all the possible combinations of A and B, and then we figured out what the value of not A or B is, and also the value of not A and not B. And we can see that no matter what our input is, no matter what combination of A and B we have, this expression is going to evaluate to the same value as this expression. So if A and B are both false, then not A or B is true, and not A and not B is true. Similarly, if A is false and B is true, then not A or B is false, and not A and not B is false. So we can see that for every row, they both evaluate to the same value. So if you have a Boolean expression that has or in parentheses and a not outside, you can think of this as distributing that not. So we distribute the exclamation mark to the two sides of that or expression, and then we change it from an or to an and. And we've got an equivalent Boolean expression. Similarly, if we have not A and B, we can distribute that not using De Morgan's laws, and we get not A or not B. So these two expressions are equivalent, and again, we can see that in our truth table over here. So if A and B are both false, then both of those expressions will evaluate to true. So every single row in our truth table needs to show that both expressions have the same value. And we have to make sure that we've come up with every possible combination of values. So we have false, 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 true, true, false, and true, true.